Next, we have Curriculum Architecture Gap Analysis, Dr. Forrest Bao.
Okay, morning guys. So my talk is, I'm probably going to focus a little bit on how to explain my technical approaches. So I hope to wake you up with some fancy slides. So this project, the goal of this project is to find the gaps between different technical training documents. For example, let's say some documents covers, for example, to drive a plane, you need to have these skills, but the training document doesn't have a good coverage of it. So I want to show you that, for example, if you have some graduate students, you want to throw them papers after papers after papers to read. Currently, some journal websites, they can do that. For example, on the left, you see it's a paper from a chemical engineering journal. And on the right-hand side, it says recommended articles. So this website by Elsevier can find the relationships between different papers, whether they are complementaries or whether they're about the same topics. So the recommendations can help you explore, just like when you go to shopping websites, say things you may like, or when you go to movies websites, say, do you want to watch this? So we want to use approach developed in artificial intelligence and natural language to somehow help solving the problem of technical gap analysis. Next one, please. Oh, sorry. Okay, so here is a hypothetical pipeline we want to use. So you can see from the input, we have two technical training documents. And the first thing we will do is we're going to do some pre-processing on the text information. For example, we're going to do parsing, tokenization. And then after that, we want to extract something called language features. For example, it could be term words, like technical term words, which are called named entities in natural language processing. And we want to do something called topical modeling. So we want to know whether different documents or different parts of the documents, they are talking about the similar things or quite different things. And also we want to do something called knowledge extraction. So because in technical trainings, there are a lot of knowledges between relationships of objects. So we want to extract them so we can know whether two documents, they cover the same kind of knowledge. And in the end, we're going to turn all those language features we extracted into something called a feature vector. So basically, it's a vector you learn in the calculus class. It's a vector of many, many numbers. And by comparing those numbers, we can use some methods called machine learning, basically supervised machine learning, such as probably you heard about, like artificial neural network, or support a vector machine, or if you're familiar with the recent news about artificial intelligence, there's something called deep learning coming out. So we can use those feature vectors and throw them to those machine learning models, and those machine learning models in the end are going to tell us, give us a quantification of the similarity or gaps between different documents. And if you're familiar with deep learning, the fancy cool thing is that all those feature extraction thing in the middle, if you use deep learning, we can probably skip all those steps. All right. Okay, thank you. I want to talk a little bit about how the topical modeling works. So take your eyes away from the slides a bit. Let's say I'm talking about food, talking about lunch today. So if I'm talking about lunch, I'm going to use a lot of words. For example, I'm going to say appetizers, forks, probably I'll say wine, those kind of words. But let's say now I'm talking about, let's go out buy a car. I'm probably talk about steering wheels, gas mileage, or let's say, what else? Maybe multimedia entertainment. So you can see when I'm talking about two topics, one about food, the other about cars, I use quite different kind of words. So this is the idea behind the topical modeling. So in topical modeling, people assume that each topic is a probabilistic distribution of words. So if I'm talking about, let's say, a pocket watch, I talk about how likely the strap is, how easy to remove this pocket watch from my pocket, whether it's small, how heavy it is. But if I'm talking about a wristwatch, I probably talk a lot of words about how it looks like. It's shining, it has diamonds on it, it looks fancy, right? So we want to use this this topical modeling approach to see whether two technical training documents cover similar topics. For example, if one technical document covers certain topics, which is not being represented at all in another document, we'll probably say, hey, there might be a gap between here. But if their topic distribution is very similar, we'll say, hey, these two documents have good coverage on the same sets of knowledge. Okay. And in the end, of course, the topical modeling only tells us the co-occurrence of different words, but we also want to know whether they talk about same knowledge. For example, if one sentence says you cannot drink water, the other sentence says you can drink water, by topical modeling, the not is being ignored, but those two knowledge are apparently conflicting with each other. So we want to extract a little bit of knowledge, and I want to show you two examples of how latest NLP research can extract knowledge. So on the left-hand side, it's the material is a conversation between a student and a teacher about a basic science knowledge. And you can see natural language processing, we can first identify some technical terms like a plastic or like a nail or oxidant, those kind of technical terms. And then we build connections between those technical terms. For example, we say, hey, if a metal, it has a property called conducting, and iron is a kind of metal, and electricity can go through metal. So we can know that iron can conduct electricity in the end. And on the right-hand side, it's a project done by Carnegie Mellon University. This project has an interesting name. It's called Never Ending Language Learning. So what they do is they feed a lot of materials, for example, news articles, NPR news, or PBS, PBS documentaries, or even Wikipedia. So the natural language processing engine can automatically learn a lot of knowledge about relations between objects. For example, on the top, they learn a really long phrase that says a bedroom containing a large walk-in closet is a kind of room. But of course, you could say, hey, that's too redundant, because we probably say, hey, if human being, we probably say, hey, bedroom is a kind of room. But you can see it's a high probability, but something is not quite right here. I don't know whether we have, for example, say, there's a university called Ivy University is a county. Apparently that's not right. A university cannot be a county unless it's a super big university. So, so these are basically, so I spent these 4 slides to basically tell you the technical approaches we're gonna use to solve these problems. Any questions? All right, thank you very much.